Hassler here. In class to introduce lesson 4.3, which is on substitution, we did some board problems, and so I thought I would work through a couple of those board problems so that you can get the idea of substitution. To start, we did some practice of just stating what the solution is to the system. When we're talking about the solution of a system, we're looking at the point where they intersect each other. So these two graphs are going to intersect each other at the point 4, 2. And so the solution is the ordered pair 4, 2. X is the y coordinate, X is 4. The y coordinate is 2. So we did a couple of these. In class, we practiced these problems by graphing. We graphed using the coordinate planes on our board, and then again, found that point of intersection. And so I'm actually just going to skip ahead to the lesson on this idea of substitution. And substitution means to replace. And so I put this on the board, and students had to determine what the solution was. And again, a solution is that ordered pair xy. So in the end, they had to tell me what x was equal to and what y was equal to. Well, actually, I already know what x is equal to. And since x is equal to -4, I can replace or substitute -4 in for x to help me find y. So I'm going to do that. And when I calculate this, I get positive 12 minus 3y equals 3. I could subtract 12 on each side. Sorry, I just want to get those out of the way there. And if I do that, I still have -3y is equal to -9. And if I divide by -3 on both sides, I get y equals 3. And so again, I have x equals -4. I have y equals 3, or as an ordered pair, my solution would be -4, 3. And again, what that means is that if I were to graph these two lines, or these two equations, I should say, then this is the point where the two would intersect each other. And so we continued this process. This time I have my y value. So again, my solution, I'm trying to find what xy would be. I have my y value, and so since y equals -5, I'm going to replace or substitute the y in the other equation with -5. I get 6x minus 3 times -5 equals -3. And now I'm just going through and using my equation solving skills. Right, I'm going to subtract 15 on both sides. If I do that, I get -18. I'm going to divide by -6, which gives me positive 3. And so I have 3 comma -5 as my solution, or my ordered pair, where these two graphs would intersect each other. And so then we leveled up and we said, okay, well, what happens if I have more than just this number, right? This time I have y equals 2x. I'm going to do the same thing. If y is equal to 2x, then I can replace y with that 2x, right? So I have -5x plus 3. I'm going to replace the y with 2x and continue on my merry way solving. It's just that instead of 3 times 2 as the number, I have 3 times 2x, which is really 6x. Rewrite everything else. I can combine these like terms. -5 plus 6 is 1x. And I'm actually done now. X equals -1. But the thing is, I don't actually know what y is yet. In the other examples, I was just given that x was equal to a specific number or y was equal to a specific number. So what I have to do is I have to take this answer of x equals -1, and I have to plug it into this equation in order to figure out what y is. Y is -2. So again, my solution, which is that ordered pair, is -1, -2. All right, let's try another one. Again, this time I have x equals 2y, so it's not a specific number, but because x is equal to 2y, I can replace x in my other equation with what it's equal to. And then I can just finish rewriting everything else. Again, negative 6 times 2 is negative 12y plus y equals 22. And if I combine these like terms, negative 12 plus 1y is negative 11y. If I divide by negative 11, I get that y is negative 2. But again, when I go to write this ordered pair, I don't actually know what x is yet. I know that y is negative 2, but I have to substitute my y answer back in to find x. So x equals 2 times negative 2, and that gives me negative 4. And so if I were to graph these two equations, they would intersect at the point negative 4, negative 2. I'm going to do a couple more with you. You can tell that as we continue, we kind of, I'll say, level up a little bit, make things a little more complicated. This problem is similar to what we just did, so I'm not going to do that one, but I am going to move on to this one. This one looks a little bit different. And this one looks a little bit different because not only do I have x equals something with y, but it's got the subtraction in here instead of that multiplication. But it's the same idea. If x is equal to negative y minus 3, I can replace x in the other equation with what it's equal to. X is equal to negative y minus 3. So I'm going to replace x with that. And then I'm going to keep rewriting that entire equation. I'm going to distribute. I get negative 4y minus 12 plus 4y equals 2. And then I'm going to combine like terms. So my like terms are this negative 4y plus 4y. And actually, when I add negative 4y plus 4y, they cancel. They go away. It becomes 0. And all I have is negative 12 equals 2. And we talked about this before. We've talked that when my variables go away, and I'm left with a statement that in this case is false, I have to give a final statement. And my final answer would be no solution. In fact, if I were to graph these would be two lines that would be parallel to each other. They never intersect, so there's no point that they have in common. Okay, I'm going to take us to, this is a problem that would be similar in that y is equal to negative 6x plus 6, and so I would substitute or replace the y in the other equation with what it is equal to. But I actually want to take us here to this problem. Because what I notice about this problem is that I do not have a y equals, I do not have an x equals. And so because I do not have a y equals or I do not have an x equals, I have to do a little bit of thinking in order to get myself in a position where I can do some math. In every other problem, there was a variable that was isolated. Like if I go back here to this problem, which we didn't do, but my y was isolated. And so since my y was isolated, I could take the negative 6x plus 6 and substitute it in. That's not the case here. But I think to myself, well, this y right here, because it has a positive coefficient of 1, would be easy to isolate. It would be easier to get it by itself. And to do that, I would have to get rid of this negative 2x. So I'm going to have to add 2x to both sides. When I do that, I get y equals 6 plus 2x. I can't combine the 6 and the 2x. They're not like terms. So I just have to write 6 plus 2x. And because y is now isolated, I can take this 6 plus 2x. And because that's equal to y, I can replace the y in the other equation with that expression, which is what we did in every single other problem. So now I have negative 4x plus 5, and in place of y, I'm going to write what y is equal to, 6 plus 2x equals 18. And now I can go through and start solving, right? Got negative 4x plus, if I distribute the 5, I have 30 plus 10x. If I combine my like terms, I have 6x. And if I subtract 30, I get negative 12. If I divide by 6, I get x is equal to negative 2. And so to find y, I can replace the x in this equation. I think that using this equation I created is the easiest one to use because y is isolated. And so if I do this calculation, 6 plus 2 times negative 2 would be 2. And so I get this ordered pair of negative 2 as my x, 2 as my y. And so this is our idea of substitution. In substitution, we are looking for an isolated variable. I'm going to replace that variable in the other equation with an expression it is equal to. And I'm going to use this process of solving equations to help me get the ordered pair in which they intersect. Now, I can check these answers on Desmos, and so I'm going to do that. So I'm going to bring up Desmos here. Graphing calculator. And this, I'm going to go ahead and type these two equations in. This negative 2x plus y equals 6, and the negative 4x plus 5y equals 18. And so let's do this. So we have negative 2x, negative 2x plus y equals 6. And down here, we have negative 4x plus 5y is equal to 18. And that point of intersection happens to be right here at that negative 2, 2, which is what we found algebraically, negative 2, 2. So it's nice to have Desmos to just check our solutions to make sure that we are doing our algebra correctly. All right, so if you have any questions, let me know, and we'll see you in class.